Hi, everybody. Today, what we're going to go through is just 6 expressions. That's it. You'll notice our title for today is Exponential Expressions 2. Really, what we're going to do is go back and kind of revisit a bunch of the stuff that we did on day 1. But now that we've got all of our rational exponents from last time, we should be good to be able to work through some more complex expressions. So let's take A and B as almost like review problems. Let's make sure we're in a good spot. So I would like you guys to go through start to finish and get a solution for A and B. Okay, pause it now. Okay, we're back. So as we worked our way through that one, I would hope that we recognize that we need to reduce that first power. So if I apply that exponent of -1 to, oops, I just wrote p twice, to all parts of that base, then we can come in on that line. I've mentioned previously, I will mention it again. Do not get so focused on a negative exponent and having to deal with, oh, wait a sec, I got to change that to a positive. Remember that we only can't have negative exponents in our final solution. That I'm okay with negative exponents existing throughout a solution. So let's make sure that we don't make our first strategy, I have to change my exponents to positives. No, I'm totally fine with doing what I just did in orange. Because now when I go through, I am multiplying powers of the same base. That means I'm going to add those exponents. And you'll notice that just my operations took care of my negative exponents. So hopefully we have what we see in orange, and we were good. Okay, let's jump in and play around with B. Well, I take a look at that and I've got a big ugly fraction that's all raised to that exponent. Maybe what I do is I want to apply that exponent to the top and the bottom. Now, I would totally imagine that I would have had a bunch of people that would have liked to have applied that -1 in. 2 very good first strategies. I'm going to take the orange route. Okay, so I'm going to ignore that blue. And what that could give me then was AB, all to the exponent +2 now, over, and now when I apply that -2 to the bottom, I need to apply to all parts. And so I come in on something like that. I would hope that we would all be pretty good to be able to simplify the top. And now, oops, I just wrote down a negative. And now, let's simplify the overall expression. So I have an a squared divided by my a to the -4th. Or I think about it as I can move that power across its fraction line so it becomes an a to the +4 on top. That's going to give me an a to the 6th on top. And if I look at my powers of b, well, I have more b's on the bottom. So my b's are on the bottom, and I have 4 more. I just want to draw your attention blindly following our power rules and how it can cause a little extra work. I'm going to get rid of that last line, and instead, I'm going to go through and blindly follow our power rules. So on top again, I would have my a squared over b squared. And here's where I say I'm dividing powers of the same base, so I'm going to subtract my exponents. I get a to the exponent 2 minus a -4, so that's 2 plus 4. And now I get my b to the exponent 2 minus 6. I want you to notice that going through and just blindly following your power laws means I may introduce a negative exponent. Now I would have to take one more step to move that power across the fraction line to write it with a positive exponent in good form. Notice I can avoid writing that negative exponent line if I just consider dealing with common factors. If I just consider moving powers across the fraction line. So it's something for you to consider as you move forward. Okay, I'm hoping regardless of pathway that we were able to get down to those two solutions. And as I said, those are two review problems for us by now. We should have been comfortable. Let's jump into some more complex expressions for today. Okay, I want you to take a look at C and D, and I want to walk through C together on this one, because I want us to maybe drill in a strategy that I think is a very useful one. By no means do I think you should always use it. But I think more often than not, it's a good first strategy. That if we are comfortable with all of our laws of exponents, then why don't we change any roots we see into exponents? Let's write them with powers. So I take a look on the top of that fraction inside my cubed, and I notice I have the fifth root of x to the eighth. So I know that 8's my power, 5's my root. On the denominator, I notice that I have the square root of x cubed. So cubed is my power, 2 is my root. And I think that that is a very good first line. More often than not, changing radicals into exponents is a good starting point. Here's where we're going to now disagree. I will have some people that are going to say, I'm going to now simplify inside the brackets and then apply the exponent 3. I'm going to have others that are going to say, I'm going to put in the exponent 3 first, then reduce my powers. I'm going to argue to you that I think the blue is a good strategy in this case. And the green is a good strategy in this case. And I'll explain why in a second. So to follow the green, I'm going to simplify on the inside. So I'm not touching that cubed yet. On the inside, I have a power base x divided by a power base x. So I'm going to get a power base x. I'm dividing powers of the same base, so I need to subtract those exponents. Well, if I'm going to subtract fifths and halves, then they need to have a common denominator of tenths. If I change 8 fifths into tenths, then that's 16 tenths. And if I change 3 halves into tenths, then that's 15 tenths. Okay, that becomes x to the 1/10, all cubed. And I can finish that off by having a power raised to exponent, so multiply my exponents. There we go. Now, why do I think the green is better? Well, it's because I take a quick peek and I notice that if I was to go through and apply that 3 into the top or the bottom, nothing's going to reduce. I'm just going to make all my numbers bigger. So I'm going to change something in the question. I want you to imagine that my denominator on the top fraction was a 3. Can you see where I would like to now multiply in that 3 because it's going to eliminate the fraction on the top? And we're all probably better working with whole numbers than fractions. So when I said, which strategy do you take, the green or the gold? I don't know. Sometimes the particular numbers will dictate what route may be more efficient. Okay, in this case, if I get rid of that 3 and I recognize that me putting that 3 in isn't going to help, then maybe what I end up having is my x to the 24 fifths over x to the 9 halves. Just make sure we don't do something silly here and say that if I multiply in that 3 to the top, I get 24 over 15 because I multiply the 3 to both parts. Keep in mind, if you multiply that 3 to both parts, you're really just multiplying by 1. 24 fifteenths is 8 fifths. It's not triple 8 fifths. So please watch out for that. I want to get rid of all that red so we don't even think. Notice when you take a look at the gold now, I've been forced to work with bigger numbers. So that's the only rub in this instance. Now I can go through and I can say, well, I'm dividing powers of the same base, so I need a common denominator, so I still have my tenths. The problem now becomes, well, now I need to work with 48 tenths. minus 45 tenths, and there's my x to the 3 tenths. So in terms of efficiency, we get there in the same number of lines, just maybe we had to do a little more calculating, work with bigger numbers. Okay, now that we've walked through that strategy of if I see some roots, then maybe it's a good idea to change them to exponents, then I think that may help out. Okay, I want you to take a look at D, and I want you to copy down D, and then I want you to go start to finish on that one. We're going to see if we match up in the end. Okay, pause it now. Okay, we're back. So the first thing I may do is just try to take a look at everything, and I notice that I have a root in there, but I also notice I have this exponent of 1.5, and I know decimals are fractions. And so maybe I'm going to look at calculating whatever I can and changing any roots, if they're left over, into exponents. Well, if you can just zero in on what I've circled in red, the top of that fraction, I hope that you're good, that we can calculate that. Because the square root of 64 is 8, and the square root of a squared is a to the 6th. Now, for anybody who's kind of puzzled by that, the square root of 64 being 8 is not a problem. So if I take the square root of a to the 12th, keep in mind, square root is an exponent 1/2. I now have a power raised to another exponent. Multiply those exponents. There's my a to the 6th. So I can just calculate what I have on the top of that fraction. Now on the bottom, I could change my exponent 1.5 into a fraction. So what I've circled in green on the bottom, maybe I do this, and I say, hey, 1.5 is just 3/2. And now I can simplify that power. So in working with it with fractions, we should be good that that gets us a to the 9th, or negative 9th, sorry. However, maybe we can just multiply those in decimal form and come to the same point. So I'm just going to get rid of that. I was able to simplify each term. Okay, here's where I take a look at that blue expression, and if I look back at the previous one, I know what approach I'm going to take. I'm actually going to take the gold approach this time. The reason for it is I take a peek and I notice I can calculate 8 to the exponent 2/3. And that will reduce really fast. 8 to the exponent 6, all to the exponent 2/3. And when I apply it to the bottom, that's going to reduce really fast. So I think I'm going to apply that 8 to the 2/3 to all parts of my fraction. Okay, let's deal with the first one. 8 to the exponent 2/3. So the cubed root of 8 is 2, square it is 4. Now I have a to the exponent 6, all to the exponent 2/3. So if we're looking at that, then we're saying we are multiplying those exponents together. That's going to give me an a to the 4th. On the denominator, we should be pretty good to be able to go through and say that I have a to the negative 9th, all to the 2/3. And so when we simplify that, we're going to get an a to the negative 6. Well, now that we have that, we should be pretty quick to say I can move that across or follow my laws of exponents. I get down to 4a to the exponent 10, and we are good. So notice we had another strategy now. The instruction did say to simplify, so if I am able to simplify anything right off the bat, then why don't I? That's going to make some things easier. You look back on question C and notice we didn't have the ability to calculate either one of those roots, so it didn't really get us there. Okay. We've got our last two problems for today. So what I want us to do, let's take each one at a time. Let's work our way through E right now, and we'll come back and we'll check our solution. So pause it now. Okay, we are back. So, taking a look at that, I now have a couple strategies. Do I want to simplify everything at the very beginning and then change any roots into powers? What order do I want to apply any outside exponents in? Well, I take a look at the top of my fraction, and I should be good that I can simplify the sixth root of x to the 18th. That shrinks way down to x cubed. Nice. I want to do that then. On my denominator, well, maybe I don't know about the fifth root of 243. So maybe off on the side, I might be doing a little factor tree. Well, it's an odd number. If I add up the digits, I get 9, so I know that 3 goes in. And if I divide 24 by 3, I get 8. And if I divide 3 by 3, I get 1. And now I stop because I know that that's 3 to the 4th. And there are 5 3s. So I can calculate the fifth root of 243. That's 3. And just as important, the fifth root of x to the 10th is x squared. That is all to the exponent 1/2. I like that as a first line. Okay, now here's where we differ a little bit. I would hope that we would simplify what we have on the inside and we can divide out an x squared from top and bottom so that we're going to shrink that down to an x over 3 all to the 1/2. And now I'm going to go through and apply in my 1/2. Now, I can write it this way. But I might argue that some people may end up missing some things if we choose to write exponents 1/2 in power form. That had I gone through and said, well, that's a root x over a root 3, then you might see why you're not done. I got a radical on the bottom, and I know I've got to get rid of that. I need to rationalize. So I'm going to work my way through in this instance, and I think a good next line would be root x over root 3. We can now see that we need to multiply that by root 3 over root 3, and that will simplify down to the root of 3x all divided by 3. Nice. If the only thing we missed in that problem was rationalizing, I think you're doing outstanding. Outstanding. Okay, we're going to tackle F. F's the last one for today. I want you to pause it now. Okay, we're back. So the first thing we notice is there's not a whole lot to calculate in this problem. Okay, so maybe now I'm trying that other strategy of I'm going to go through and change my radicals into roots. So if I focus in on the top of that fraction, I have a big square root, so I have a big exponent 1/2. On the inside, I'm multiplying powers of the same base. So in what I've just boxed in green, I'm taking an x and I'm multiplying it by x to the exponent 2n plus 1. If I multiply powers of the same base, that means I add my exponents. Okay, I take a look in the bottom, and I'm going to change my root into an exponent. I think that's a great first line. Okay, I think that motivates me then to want to just fully simplify the top and fully simplify the bottom. So let's go ahead. We have a power raised to another exponent, so I'm going to multiply my exponents. Because my 2n plus 2 is multiple terms, I need to make sure that I expand my 1/2 in. So on top, that's going to give me something nice and neat. Just an exponent of n plus 1. On the bottom, I notice the same sort of thing happens. When I now take my exponent 1/3 and multiply that to my 3n, then that's going to clean up to just an n, which is really nice. And now I'm dividing powers of the same base, so I'm going to subtract those exponents, and we should be able to come in right on with an x. Now, if we struggle with that x a little bit, just keep in mind that it's n plus 1 minus your n. And so we notice that our n's are going to cancel out. And of course, we don't write the 1. So I'm going to get rid of that gold, and we are good. Okay, so all you notice is that we end up dealing with some uglier expressions. No problem, we have some strategies. Try to simplify everything that we can. Try to change our radicals into exponents. And then we just need to follow our power laws to simplify our expressions down. Okay, the rest of this time then should act as almost like a work period for you. This is a real opportunity for you to now work your way through and get as much practice solving these puzzles as you can. Okay, good luck.